Hey everyone, this is Sai Priya Veerabhuma, and this is my submission of Dinera for the Palo Alto Networks Hackathon. So basically, me being an international student, it was pretty difficult for me to manage my finances. And I got to know that it's not only me, pretty much all the teenagers, all the youth, everyone are in the same boat, I would say. So this is your one-stop solution. So how about sometimes $500 for food can be a little okay for a student. At the same time, it's pretty burden for few. So this is where Dinera comes. So Dinera is a Python-based platform where it calculates your bank transactions, understands you as a person, and also gives you suggestions on how you can save some money. And here you can see that this is my GitHub repository where I have given the application. So this entire application has been deployed on Google Cloud, and the front end is React.js, and also the back end is Python Vast API. So we have built a chatbot where you can have a conversational regarding your financial transactions and understanding on how well you can track and how well you can spend so that you can save some money. A little more about it is coming to the technical integrations. So for the login integration, I have used a clerk for the authentication, and then we upload our bank transactions because this was just a prototype for a hackathon. So for now, I have put a position of a provision where the user can upload a CSV file of their transactions, and later this gets into the SQLite database, and the data is processed in such a way that with the logistic regression machine learning algorithm, in a way that it analyzes different patterns and different scenario. That's what the model has been trained upon. And I have used OpenAI's GPT-4o model for the LLM support, and this understands our bank transactions and the transformations whichever I've done, and that is being fed through an encryption layer for the AI chatbot, and through that it can assist you. And also we also have a important feature called anomaly detectors, which basically understands if there is any huge transaction or happening all of the sudden. And also me, including, there will be many people who just forgot, like for the subscriptions, let it be Spotify, Amazon, or some random ones we just wanted to do for a free trial, and we are stuck with it, and I've totally forgotten about it. So this Danera detects and determines the pattern and understands if there are any such and flags it to us so that it's easy visible if there is any recurring patterns going on. So this is a simple overview about it. And uh, before getting into the application, I would say we'll quickly get into the documentation and then go through it. So, like I mentioned, the backend is Fast API, and I have used SQLite for the database because I didn't had only for the prototype data processing, I would say. And for visualizations, I've used React charts, and for the authentication, like I mentioned, I've used Clerk, and it's been deployed on the Google Cloud platform. So the main, also a fun feature, I would say, there's a fortune cookie teller which cracks a random insight or a joke based on our visualizations or the insights, and it just gives a mood lightening kind of a message, I would say. Yes. And coming to the problem statement, like I've said, there are hundreds of people who really are stuck into this, and this can be a really good solution considering many bank applications wouldn't actually help us in a personalized manner or detect some recurring charges. So this is where it comes into the place. I have researched a little about how frequently users are suffering in this particular. Coming to the subscription zone, I would say there are lakhs of users who just fall into the subscription trap where they just forget to unsubscribe even though they aren't using it, which actually deducts upon $30 to $50. And considering this as a huge chunk of people belonging to 20 to 30s, so most of the students, I would say 30s, and very important or something for the saving, I would say. So here for the anomaly detection in the main place, I have used the isolation forest algorithm. So basically, depending on the data split, I have determined it in the such a way that it'll either use the AI side, if not with the few metrics, it will just pass through and give the insights. And most of my features on which I've done feature engineering and trained my ML model are that based on the Z score and understanding, and how, based on the merchant frequency or how many times has it been flagged with different vendors. And these are few of the metrics I had to take into consideration while training the model. And then later, I have done pattern analysis and priority ranking. So based on all of these, I have trained the model and given up the product. So this is my front-end tech stack. This is my back-end tech stack. And like I've mentioned, we have only utilized CSV for now, and maybe we can get into the other, the future upgradations of this application would be integrating into different data formats and also integrating it with Plaid so that we can get the direct bank transactions into this. That would be the expansion of this. And right now, I've just chosen this model because keeping the application a little light and focusing on the smaller data sites, I would say. And for the entire software development practices, I did follow Agile. I have maintained GitHub issues and kept track of it by splitting. So also before getting into the development of the application, I have maintained a document first approach so that I have done entire system design, understanding with the low level design of what exactly the application should be have and what exactly the product features based on the customer's requirement. And that's how I've started this. And talking about the crucial layer of our application, which is the ML anomaly detection layer, like I just mentioned about it. So whenever the user uploads the data, it gets into the anomaly analyzer. So exactly what happens is the transactions checked out. Like I said, based on the size of the transactions, it just splits into two. This is just done for the time being, considering the sample size and being this as a prototype. So if it's less than if it's less than 50 transactions, it just gets to the rules, which is Z-score statistical analysis, and it will calculate the mean, it will understand the Z-score threshold and check whatever it's near to that. And based on those observations, it will flag the transactions and it will reason it into the categories. And that has been given to the dashboards. If my data size is more than 50, that's when the isolation, the ML model comes into the place. So I extract it by I have put few feature engineering metrics where it will be extracted based on different factors. Few of it may be like amount, day of the week, hour of the day, which category does it belong, how frequently is it recurring, and what kind of vendor is it. So these are few of the things which I have considered while training the model. And after that, the model has been trained and it will predict the anomalies. After calculating it, again, it flags the transactions based on the calculation. And that's when it get back and displays to the user. So these I have just given few description of the examples on the detailed pattern or how exactly is it happening. Like over here, like I mentioned, it's 3.2 times higher than your average in this particular category. So are you sure if this is you? Most of our banks already does this because if you have ever observed, whenever you try purchasing a unusual amount for your spending or your deposits, like purchasing a laptop all of a sudden, or a phone or a car in a single payment, or any such huge transactions, usually the bank sends us a alert saying that, can you please confirm if this is you or the card has been stolen? So these are for the privacy considerations. So these are what which I have taken into the account. And the next one